Welcome to episode 53 of FTCE Seminar, a teacher certification podcast. I'm your host, Mercedes Musto. Today we'll be talking about algebra to help you prepare for the FTCE General Knowledge Mathematics subtest. More specifically, we will be learning about relations that satisfy the definition of a function. So let's get started. Concept 1, functions. Functions? That sounds impressive. But what exactly are they? Okay, imagine a machine that takes in one input, like a number, and always gives you exactly one output, another number, based on a rule. That's the essence of a function. But wait, there's more. So some relationships are functions and some aren't functions. What's the difference? Here's the key. In a true function, for every single input, there can only be one output. Now, imagine a light switch. You flip it on, input, and the light turns on, output. But if you flip it off, another input, the light also turns off, same output. That wouldn't be a function because one input has two possible outputs. Not a function. See? Right. That makes sense. So how do we know for sure if a relationship is a function or not? Good question. One way to do this is with the vertical line test. Imagine a coordinate plane with the x and y axis labeled. Now, imagine a vertical line drawn anywhere across the graph of the relationship. If that line intersects the graph multiple times, it is not a function. Why? Because that single input value, the x-coordinate where the line intersects, would have multiple output values, the y-coordinates of each intersection point. So, if the vertical line intersects the graph more than once, then that graph does not define a function. Exactly, because a function has only one output for each input. Let's try some examples. This may help. This time, imagine a function table with two columns where the relationship between the input is x and the output is y. When we input a value for x, then we get a value for y. Let's apply this to an example. If I have the equation y equals 2x plus 3, and on my function table, I put in a 1 for that x, we're going to apply that. And I would get y equals 2 times 1 plus 3. That would equal 5. So my y would equal 5. See? Let's try this again. Then on the function table, let's say 2 is the next number for x in the y equals 2x plus 3. Let's apply that. Then that would make y equal 11. Stay with me now. So your function table would read like this. In row 1, you would have x equals 1, y equals 5, or coordinates, parentheses 1, 5, parentheses. Then in row 2, x would equal 2 and y would equal 11, or parentheses 2, 11, parentheses. This is a function. See, if I put in 1, I get 5. If I put in 2, I get 11. There's always one output for each input. Precisely. The graph of this relationship would be a straight line, and no matter where you draw a vertical line in the vertical line test, it would only intersect that line once. Question: how do we identify if a relation qualifies as a function in a real-world scenario? Okay, imagine you're running a lemonade stand. For every cup you sell, the input, you charge a fixed price, the output. This creates a relation between the number of cups sold and the total amount earned. But is this relation a function? To answer that, we need to understand the key idea behind functions. And remember, each input must have exactly one output. In our lemonade stand example, for every cup sold input, there's a unique price paid output. This aligns perfectly with the definition of a function. Here's where things can get tricky. Let's say you decide to offer discounts for buying multiple cups. Now, for the same input, number of cups sold, there could also be two outputs, price with the discount and price without the discount. This relation is no longer a function. So how do we prove this scenario is or isn't a function? Well, think about it, but not too long. That's right, we can use a vertical line test. Imagine a vertical line drawn anywhere across the graph representing the relation. If the line intersects the graph at multiple points for a single input, then it's not a function. Let's revisit our lemonade stand discount scenario. If we draw a vertical line, it might intersect the graph twice. Where? Well, once for the non-discounted price of lemonade and another for the discounted price of lemonade for the same number of cups sold. Therefore, two outputs, not a function. Remember, functions are like well-organized machines. Each input goes through a defined process and produces a single, predictable output. And don't forget, the vertical line test is a visual way to check if this single output rule has been followed. For more practice with math, visit FTCEseminar.com to study for the test. The important thing is to start studying today so you can pass the teacher certification exam. Well, hey, what are you waiting for? Check us out on YouTube at FTCE Seminar and start studying today. This podcast was recorded at the Pickens Multimedia Studio at the University of West Florida. This podcast is listener supported. Contributions can be made via the listener support link on Spotify, or you can buy me a coffee at FTCEseminar.com. This is your host, Mercedes Musto. Join me again on FTCE Seminar, a teacher certification podcast, so you can pass the FTCE.